In this video, I will show you how to do some statistical analysis within Google Earth Engine. So I will use DHS survey points beside nighttime light data to make a regression between nighttime light data and DHS values. Our procedure is not highly dependent on available algorithms and also is not pure programming. It's a mixture between the programming skills and also using available models. So let's start by importing DHS points. DHS. Saving this script into the created repository, workshop, poverty, the fourth one, regression. Okay. First, let's take a look at the DHS survey points, similar to what we did in the previous video. Variable DHS in region of interest equate. First, let's print it. Print DHS dot aggregate histogram, similar to what we did to create a histogram of feature for the country. Okay, running this script, and I want to have access to the list of the countries that are available within the DHS survey. So I start with Angular, variable DHS ROI equate DHS dot filter EE filter dot equate the country equate Angular. Okay, and let's print the available years for Angular. DHS region of interest, aggregate histogram, and we are looking at the available years. The available years for Angular is 2006, 2007, 2010, 2011, and 2015 and 2016. So let's select a date and create the DHS region of interest for this year. For example, dot filter DHS, we are going to filter the year and equates 2011. Okay. In the previous video, you have seen how we fetch Landsat data and show the Landsat data in our region of interest. Now we are going to use nighttime light data. So here we search about nighttime light data. It provides us a list of available nighttime light data, DMSP, OLS nighttime light data, and VIRS nighttime light data are the two main sources that are available within the Google Earth Engine. So I selected DMSP-OLS nighttime light data because I want to analyze using 2000 element data. Let's take a look. Running this script, and I want to have access to the list of the countries that are available within the DHS survey. So I start with Angular, variable DHS ROI equate DHS dot filter EE filter dot equate the country equate Angular. Okay, and let's print the available years for Angular. DHS region of interest, aggregate histogram, and we are looking at the available years. The available years for Angular is 2006, 2007, 2010, 2011, and 2015 and 2016. So let's select a date and create the DHS region of interest for this year. For example, dot filter DHS, we are going to filter the year and equates 2011. Okay. In the previous video, you have seen how we fetch Landsat data and show the Landsat data in our region of interest. Now we are going to use nighttime light data. So here we search about nighttime light data. It provides us a list of available nighttime light data, DMSP OLS nighttime light data, and VIRS nighttime light data are the two main sources that are available within the Google Earth engine. So I selected DMSP OLS nighttime light data because I want to analyze using 2000 element data. Let's take a look before selecting one data. For example, for DMSP OLS nighttime light data that I will import, the data is available from 1992 to 2014. But for example here, for VIRS nighttime light data, which is here, for example, one of the, okay, it's available from 2012 until now. So the technology within the VIRS nighttime light data is higher than the MSP nighttime light data. However, I'm interested in the MSP collection. The MSP collection, okay, similar to what we did for Landsat collection, variable DMSP collection, filtered, equate the name of the collection, and let's take a look at its bands. It has 4 bands, and what I'm interested in is a stable light. A stable light is the cleaned up of average visible band light. So it has higher accuracy than the first band. So we will use this band. You see here we have the nighttime light band. So we mainly have one band. The others are about is cloud free or not. Then the stable light is the corrected band that is created by the main average of visible band. So mainly this satellite is generating one band. So it's not multi-spectral band, but similar to we had in Landsat data. So here we are going to select our interested band, a stable light, let's that filter bounds in our region of interest of DHS region of interest, and filter date. That's filter date. Okay, from 2011, the first day of the first month, until 2012, and as I said, the end date is exclusive, so we are using the nighttime light data, filtering in our region of interest. I'm not sure if nighttime light data can be filtered by region of interest. I think the average of monthly data is created for in global scale. However, we will put the filter bounds. Filter date is fine, selecting the interested band and creating an image from the image collection. As you remember, we aggregate the image collection into one single image. So the MSP collection filter, let's tell it the MSP image, because now it's the image, not the MSP collection. Okay, map.add layer, the MSP image, no visualization, the MSP image name, and false. Save and running the script. Let's also add the DHS ROI into the map to take a look at. Okay, running the script, the MSP image, DHS ROI. Here we are in Angular, and the DMSP image visualization is not very well, but we can select an storage, for example, from 0 to 4. Let's take a look. It's better, not too bad. Okay, 0 to 63. So the mean is 0 and the maximum is 63, and consider it's just for the visualization. I mean, it doesn't change any values for statistical analysis. It's just for the visualization, determining the mean value and the max value for the visualization. Okay. Here we have the nighttime light data at the background, and the foreground we have several DHS points. And now what we are doing is to sampling the nighttime light data at DHS server locations. Okay, so the next step is sampling. Variable samples equate. We are going to sample the MSP image, and for sampling we have sample we have sample region command. Let's take a look at this command. Sample regions takes collection, properties, scale, and the others are not very important. Okay. Collection is a feature collection that we are going to sample within this DMSP image. So the collection is the DHS ROI. Properties is the, you can see here, properties is a property within the feature. I mean, here we have the DHS collection, and the feature that we are interested in is IWI feature. So we are just sampling from the IWI, and also a scale is required for the sampling. We can define and a scale. So here, let's print the samples. Print samples. Save and running the script. Now for properties, it should be provided as a list. Running the algorithm, and here the output, I mean the samples, is a kind of a feature collection. It has 254 elements, I mean 254 features, and each feature should have two values. One IWI values, and another one is a stable light values, because we are sampling a stable light using DHS points. So let's take a look at these features. For example, the first feature has two properties: IWI value 14, stable light 0. Another one, IWI 14, stable light 0. IWI 58, stable light 63. IWI 33, and stable light is 20. Now we have a feature collection. Each feature has two properties. I mean the target data and the input data, and we are going to provide just a simple linear regression to to formulate between the nighttime light data and IWI values. So this is our next step. Regression, variable, regression equates. Okay, we are working with samples and we are aggregating. I mean, not the aggregation similar to what we did here, but it's a kind of aggregation. But here we use the command reduce columns. Reduce columns will be applied to a feature collection, and we can define the reducer. Let's use the reduce columns. Our reducer, now I think you know what the reducer are. Reducer are what reduces from feature collection to feature, from two columns in the feature collection to a linear model, or whatever we reduce from an image collection to an image, from an image to a mean value of image. Reducer are what we reduce from a bigger collection to a smaller collection. So here our reducer will be the linear regression model, and then the selectors and the weights will be the same, so it will not be defined. Okay. Here is our simple linear regression model as a reducer. EE reducer linear regression. Number of input is 1 and number of output is also 1. And our selectors, what we are going to reduce, I mean, this is the sample, it's a feature collection. We are going to reduce the columns with this reducer. But what columns are going to be reduced? So here we define the name of the color that are going to be reduced. The names are here: stable lights, and also the IWI. I mean, as the input data and as the target data. And let's print the regression to see the results. Save and run the script. Here is the result. I mean, it's a simple regression, so we have the result. Now let's go to the next step to see what's the accuracy of this regression. Okay, variable. First, let's extract the values. I mean, variable C equates from regression dot get coefficients, and coefficient is two-dimensional because coefficients, I mean, we could have multiple coefficients if we have multiple inputs. So we are going to get 0 and 0 as the coefficient. Print C regression dot get is not a function. Okay, let's cast it with EE array to change it to EE array, and then okay. Okay, it works. Just to show that, we just get a coefficient as a single number to create the IWI prime. I mean the output of our regression model. So variable R equates in a similar way. To accelerate the procedure, just copying and paste. E array regression, we just copying it from here, and because it's one dimension, just get 0, and also print R. Save and run. Okay. And now we are going to create variable IWI2. I mean, the output of the regression model is the before creating this one, let's change these columns